Okay, you're showing me how we're going to log into this. Go ahead. Yeah.
Okay, so we're going to use our super user account since that gives us full privileges into this excuse me, into the system. So by using the admin account.
And I'll be able to use the UI to change those passwords?
Correct. So set with 3 default users, which are the admin, monitor, and operator user accounts.
Okay.
And only the admin can modify any settings with the users.
Right.
So let's log in.
IPQ Control Center. Pretty clear. There's an arrow telling me that that's how I get to access the advanced features of IPQ. Now I understand IPQ devices have an IP address. How do I resolve conflicts on my network?
Our system ships with a default IP address that has to be accessed locally using either a PC or a laptop. Once you are logged into the system, go to this IP address menu selection, and by clicking inside this page now, you're basically given the ability to change the IP address.
Okay, so let's have a look at how I set up IPQ.
Okay, so the first step you want to do is to go into this IPQ configuration page. What we're seeing right now are the default settings that it ships from the factory. So by default, IPQ is always turned on. We're set at a 0.02 target loss rate. With our minimized band feature turned off, and as you can see the other values, these are all default values that ship from the factory.
Okay.
By browsing down the page, you can change these settings to whatever suits your deployment.
So go back up. The top part of the page shows me the current setup.
Correct. So these are the current settings.
I scroll down below that report.
Correct.
And that's where I have the places I can make the changes. All right.
So in here you can change things like the IPQ protection. So again, by default, we're always in an active state. But you can basically go from a active to monitoring and a monitoring to an off state. So
when I'm monitoring, there's no IPQ protection going on. Is that right?
Correct. So in the monitoring state, we're simply monitoring the network conditions, but there's no IPQ protection taking place.
Okay. Target loss rate. What is that?
So the target loss rate is what we try to achieve. So for instance, if you're running at a 1% packet loss rate, we're going to try to bring that down to, in its current setting, into a 0.2%.
And that's the shipping default. I can go really aggressive to 0.04, or I can relax it to 0.4 and something in between.
Correct. The 0.04 and the 0.1% are features only available in our telepresence bundle, while the 0.2 and 0.4% are available in all our models.
Minimized bandwidth, I presume that has to do with overhead?
That's correct. So if you're running an environment where you know you have a certain amount of bandwidth available to do your video call, the minimized bandwidth feature allows you to only ever use a maximum of 12% overhead on top of your video call.
The system will do its best to reach the target loss rate, but it'll never go more than 12% the call rate? Is that how it works?
Correct.
Okay. All right, so burst loss is like consecutive packets lost as opposed to one here and one there, which is a more typical scenario. So burst loss protection, looks like we have a way to handle that?
Yeah, so if we have the ability to help a network that is seeing burst loss, we have buffer space anywhere from 0 up to 100 milliseconds to protect against that kind of loss.
Okay, so I'm willing to withstand up to 100 milliseconds, but maybe something less than that in terms of latency. I can get good packet protection against burst loss.
Correct. We will use up to that value.
So again, whatever you put in that buffer in terms of milliseconds is the maximum, but you won't always use it, but you never go more than that.
Correct.
Okay. I see down below there's some legacy support for DMZ.
Correct. So in cases where the DMZ is running with some older style routers or switches, we've added some features here to allow IPQ to work in those environments.
Okay. So let's scroll back up. What's the next thing that we want to talk about here?
So the one other feature you can look at is what we call our policy filters page.
Okay.
This allows you to do some more fine-tuning of the system. It allows you to select devices that you want to be protected by IPQ. If there are certain protocols or applications you know that you do not want to be impacted by IPQ or that you want to protect with IPQ, you have that full ability to do that right now.
Okay, so for the most part, I've been thinking of this as a way of helping with my video conferencing over the top over the public internet. But what you're saying is you can get more specific than that as well, and it really is a network protection tool, a way of adding quality to broadband. Is that right?
Correct. So you can now specifically target certain applications to have IPQ protection, while certain applications do not require the IPQ protection since they are not as sensitive to packet loss as others.
Email, for instance, it doesn't matter if it takes a couple extra seconds for email to arrive, but I can't stand a couple extra seconds for a response to come through in a video conference.
Exactly. So video is more susceptible to loss, so you want to basically ensure that you have full protection for your video streams while with your email or regular web traffic, you don't really care.
Okay, so I think I got a general understanding of how IPQ is set up, and it can go quite detailed on it, but we have a video conference call going right now, and I know we've got the simulator turned on, so we're actually injecting loss on this call right now. Can we look at the stats? Is that a good place to go next?
Exactly. So, yeah. So right now what we're seeing is we're actually simulating a loss of roughly about 1.5% receiving back to our end.
Can we see that?
So then that's visible right here. So again, within the top values here, we're showing that we actually are working. So again, every time you refresh this page, the page will refresh with new values. But again, the first top values here are very representative of the actual action that's taking place. And with that 1.5% packet loss that we're currently injecting, you can see that here in the received network loss. So the received network loss is what the current network is seeing in terms of its loss.
Okay, so in this case, we're on a LAN, and this system over here is just around the corner in our office. It's nice and clean. There's not a lot of packet loss, but if we were going over broadband, we might be seeing about 1.5%.
Correct. So
in general. So we've injected it here to simulate an actual broadband link.
When we're running with roughly 1.5% packet loss, our IPQ protection, because it is working with this current video call in progress, we're actually noticing that 1.5% packet loss is now being reduced to 0.07%.
Okay, now I saw that we had this set at 0.2% as a target loss rate. We're doing far better than that.
Best effort can go all the way down to 0% if we can achieve that.
Okay. What else?
So some other values that are useful to know is, again, you basically have full visibility into the entire network. You have visibility into the amount of throughput, as well as the current activity table, which shows you how many active IPQ sessions are being used. And a good next step to see is basically in a more visual perspective of how well IPQ is actually working. So again, here we have more text-based information, but now we can go and see some more graphical by going to what we call our packet loss history graph. Again, everything in red, which we're seeing on the screen now, is what is the actual native network loss in the system. So basically, whatever the connection is between the two IPQ devices or the two video systems, this is the amount of network loss that we're currently experiencing. While everything in blue is what we're actually able to correct that loss down to.
Okay, so I said that we're on a LAN and it's pretty clean. There is no packet loss, and we were injecting 1.5, but I can see it all over the place. Does that tell me that there's packet loss on all networks?
It's quite possible. So every network is different in terms of its deployment, what kind of devices it has. So there are certain points in a network where they could be causing congestion, which causes packet loss.
Okay.
But again, our simulator is completely random, so there are points where you try to achieve a 0.5, but you might see spikes above the 0.5 or below the 0.5 to give you that average of 1.5.
Okay, I understand. Well, all in all, I could see that if I didn't have IPQ turned on, if I wasn't protected, I'd be having a pretty lousy experience. Can you show me what a lousy experience looks like?
Sure.
Okay. I'm at the other end of that video conference call we were looking at earlier. Now, I understand we're running clean now. Is that right?
That's correct. So we're running in a clean environment, and our IPQ protection right now is set at a monitoring stage, which basically means that even though we will be increasing the packet loss to show how things can degrade, we will still not be adding any protection to the screen.
Okay, so you're telling me that we're running clean, and now you're going to use that network loss simulator that we looked at earlier, and you're going to punch a little bit of packet loss into this connection.
Correct. So we'll start around a 1% on both ends and seeing how that will actually impact the video. So right now, once I get here, click verify. What we'll start seeing in a few seconds, it takes about 5 seconds for this to kick in, is the actual...
Not even that.
Oh.
Not even that. You're looking awful already.
Yeah, so if I go now to the graph, you can now start seeing that once I refresh this page now, is that we actually are experiencing about a 1% packet loss. And that's indicative because both the red line and the blue line are basically fairly close to matching each other in terms of their protection. So right now there actually is no protection taking place.
Right, okay.
Wave your hand so we can see kind of how the quality has degraded. So you can see there's definitely artifacts taking place on our side here. Yeah.
Right. Okay. That's good. How about this? Can you see this nicely?
Yeah, your hand kind of disappeared for a second, but...
Okay, I gotcha. Push it up a little bit. I mean,
okay.
My end of this video conference call looks a little bit nasty. It's not clean the way we like it. But I know that there's some networks out there, some broadband links that people use to try to do video conferencing over that can have 2 or 3%. Can you push it up to 2 or 3?
Yeah, we'll put it up to 3% on both the transmit and receive. So we'll see how that now looks. This should actually degrade it fairly bad to the point where it'd be quite annoying to use this kind of connection. Oh yes.
Okay, waiting. What's happening? Can you see? Okay, so yeah, it's freezing.
Oh yeah, your picture here is bad. You've frozen. Yeah. So,
okay.
So again, going back to the graph now, which will basically show you that we've now increased from this 1% where we were earlier, now up to this 3% right now. Again, still no protection, but
right.
This is what your average user could experience with these kind of network conditions.
Okay, so show me the current conditions, or the statistics, right? That's what I want to look at. The statistics. I need a reminder of what our settings are, what our target loss rate is.
Yeah, so if we go back now, and if we go into our statistics, our configuration right now, which we have, is a 0.2% target loss rate
right.
with that system, with
right.
our current system.
Yeah, okay. And what are we doing? Are we monitoring now?
So in this stage here, we are monitoring.
Okay, right. So we're going to turn on.
Yeah, so what I'm going to do is basically change this from a monitoring stage into what we call as our active stage.
Right.
So by going down here and now changing it to the active, and click change. Again, still running with the 3% loss and the bad quality, and verify.
Yeah.
What we'll do now is going back to the graph. And clicking this refresh button.
Look at that.
We can now see that the picture on our side has dramatically improved in the experience and the quality. Still, once in a while, there might be the occasional blip and artifacts, but it's well much better than what it was. And we can also see that the graph, it's still constantly seeing packet loss at roughly a 3% packet loss, but we're bringing that connection down well below 0.5, which is the lowest scale point we have right now.
Okay.
And if we actually go to a bit more detail, just for the people that would like to see more statistics, is if we go to the stats page right now, we clear the counter so we get some new data for the current conditions, and refresh. We can now see that we're still seeing roughly a 3.3% packet loss, but we're bringing that down to what our target loss rate is, which is 0.2, and we're pretty close. We're at 0.17. So if I were to refresh this again, as the averages kick in, we are now at 2.75 for the cumulative, and we're seeing right on the dot of 0.21% our target loss achieved.
Okay, so we've just demonstrated we've gone from clean, we've simulated a typical broadband network in the 1% range. We pushed it up to a really bad broadband link range of about 3%. Then we simply turned on IPQ and boom, it's cleaned it all up, and it's a nice crisp video conference experience now.
Exactly.
Excellent. Yeah. Thanks, Matt.
No problem.
Thank you.